All right, welcome back. It is time for Advent of Code. The snow is coming down here in New York. We're getting buried, but luckily Advent of Code goes on. We're on to day 16, and hopefully it'll be a good one. Looking forward to it. Haven't seen the problem yet, as always. Quick shout out to the two folks commented on some of the previous videos. Always good to see people are watching, that people do find this interesting. So thank you for leaving your comments. Appreciate watching. I'm glad that this is helpful. That's definitely part of why I do this. And yeah, let me know how I can improve these streams and what questions you have. So yeah, I've got the code set up as usual. So let's dive right in. Let's switch over to the desktop, start our stopwatch, and roll into it. On to day 16. We're doing ticket translation. As we're walking to yet another connecting flight. This is just going to be a bunch of connecting flights, this whole thing. One of the legs of your rerouted trip is coming up, is on a high-speed train. The train ticket you're given is a language you don't understand. You should probably figure out what it says. Yeah, that's probably fair. Unfortunately, you can't actually read the words on the ticket. What are you going to do? Listen to them? You can read the numbers, so you figure out the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the numbers on your ticket, and the numbers on other nearby tickets into a single document. Okay. So we're going to collect a bunch of train tickets, the rules and people's various train ticket numbers, including your own, and try to figure it out. The rules for ticket fields specify a list of fields that can exist somewhere on the ticket and the valid ranges for each field. A rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1 to 3 or 5 to 7, inclusive, such that 3 and 5 are both valid, but 4 is not. Each ticket is represented by a single line of common separate values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. Consider this ticket, ? What happened to comma separated values? This ticket might be represented as these numbers. The actual train tickets we're looking at are much more complicated than this. Geez, this is going to have a lot of numbers. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field, the second number is always a different specific field. You just don't know what each position actually means. Okay, so the positions are locked. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. I mean, we don't even know which one is your ticket at this point. Oh, it actually says your ticket. Fair enough. Suppose you have the following notes. It doesn't matter which position corresponds to which field. You can identify nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values, class, row, seat, your ticket. The values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. The values 4, 55, and 12 are not valid for any field. Adding together all of the invalid values produces your ticket scanning error rate. What? Sure, if we want to call it that. I don't know that it's really a rate though. Consider about what is your, okay, so it's just the sum of the invalid values that don't fit into any of these rules. So we can have like a cascading if kind of thing. Let's take a look how bad this puzzle output is. Substantial. Oh man. Oh, part 2 is going to be a doozy, isn't it? All right, let's paste in our inputs. Here's our big input. Here is our little input. Here we go. Paste that in there. And I'm thinking we're going to do manual parsing for this one. Yeah, we're not going to use the utility in this case. I don't think, I mean, you could, right? It's just that it would get you these blanks. And so it just splits awkward. Feel like it'd be easier to do some manual parsing here. All right, manual parsing mode. Boom, boom, boom. We're gonna get rid of this. We're gonna call this file name, and we're gonna delete parse1. Yeah, we're gonna use small. Great. So what I want to do is for with open file name as f dot read dot split lines. Oh no, not this one. We're gonna do f dot read dot split on the double new lines. We're gonna use that strategy to get our sections. So that'll be rules, my ticket, and nearby. So rules, my ticket, and nearby ticket. So that should look something like this. Let's just return this to make sure that looks right. And we have something like this. Seems good to me. Yep, and then we have the new lines are embedded in here. So now we can do for each of these, I mean, kind of want these all to be new lines split anyway, don't we? Eventually. But I feel like they're going to be processed differently, maybe. All right, let's do it this way. Let's call this rules, process rules. And we're going to take that one line of rules. We'll take line dot split on new line. So this is going to be process rules on rules. And it's going to get back, let's just save it back to rules. We're going to split on new lines. And I'm going to move this over. Let's split on new lines, then split each of those on colon space. And then we'll have like the name of the rule and then the numerical chunk. So let's do line dot split equals lines. And it seems like this is still having this weird spacing error. Okay. Then for each line, we're going to split by the little colon space. Which, can we get away with doing that in one line? Don't think I want to. I mean, we could, right? But like, because you can say L dot split on colon space, and then just like have this be a list comprehension. For L in lines, because that'll make a list. I don't want a list of lists though in this case, so that's actually messier than I would like. So for line L in lines, we're going to split by colon, so then it'll be rule name, comma, num ranges. So that's this split. And the name will stay as a string. The num ranges now need to be, let's take a look at some of the real examples here. Is it always? Yeah, so here's our exact thing. There's always two things. No more, no less. So we're gonna split this num ranges dot split on or with spaces around it. And that'll give us, or actually there's always two ranges, right? So first, second, and then we want to, whoa, I just went to the git log. So we split by or, then we have to split by dash. First dot split on dash, and second dot split on dash. And so then it'll be like two ranges. Okay, first start to first end, second start to second end. Yeah, and I think I want to print this whole thing out so I can verify these things. So what do we got here? Rule name with a first start. Let's do it this way. Do some F strings here. First start to first end. Yeah, or I know we're just recreating it, but like this is good parsing. Oh, and we also need to turn these into ints. Blast. Oh, but here I can do map int. No, not int of that. Map. I saw this on one of the solutions from one of the previous weeks. And I was like, that is a clever way to take care of this problem where it returns a list, and I want to do int for each of them, right? We want to do int of first and of this one. So that should handle that. And I can just do a quick type of second end equals int. And I can just assert that. Start or till second end. Is that the whole rule? Basically. And we want to print that. I'm already calling process rules. It returns lines, you know, we'll deal with that. And this will print that whole thing. All right, let's run it and see. So here we go. Class 1 to 3 or 5 to 7. Okay, that looks good to me. And then yeah, our string, which we don't care about. So now we have our rules. So now we need to kind of send that into some sort of construct that can interpret it, basically. Because right now it's kind of a loose hodgepodge, for lack of a better term, right? So every rule has two things with an upper and a lower. So I'm thinking we can structure this something like a dictionary with a rule name, right? So like whatever rule name, and that'll go to a list of 4 values. Is it always 4 values? It does seem that way. So 4 values, F1, F2, S1, S2. So this is first one, and then first end, and then S is second. I don't know if that's the best way to do it ever. Maybe we can call it A and B. A1, A2, B1, B2. And so then we'll have another rule. So for each rule, we'll get the name. We'll have its corresponding values stored. Yeah, seems decent enough. I have to assume we're going to need those names later. Like, I think it would be foolish of me to think or hope otherwise. So for each line, line dot split. Oh, these are all the rules. All the rules as one thing. So we can make our dictionary here. So rules equals dictionary, and we're going to say rules at rule name equals this list of first start, first end, followed by second start, second end. And let's return rules. And then we print out rules. So there's our little class, 1, 3, 5, 7, 6, 11, 33, 34. Great. So that's the first bit. And we're going to skip your ticket. my ticket, whatever you want to call it. And we're going to look at these nearby tickets. So now we need to get the nearby tickets turned into some numbers, and we need to pull out the numbers that are not working. So these are single tickets with a bunch of numbers. So these are just split by new line, split by comma, skip the first element that says nearby ticket, and map it to an int. Yeah. So let's process tickets. Nearby tickets. Something like that. Let's define a new function here. Okay. Of these tickets, really it's a string. String.split again. We're going to split on new line as before. And so that will have, because you can see here our nearby tickets are all new line separated. It's all still one big blob. And we don't want the first one. So when we split it, we're going to get that first one. So we'll dot split, we'll say from 1 to the end. And so these are our actual tickets. And then each of those need to get split by comma. So for tickets, for t in tickets, t dot split by comma, and then we'll do the map of int to the output of that list as before. And we have ticket values, something like that. So let me remind myself, we have these numbers coming out, and for each of these numbers we're going to need to check if it's in any valid field. So I'm thinking a list of lists here. Ticket list, and we're gonna have a map of the int. So these are ticket values. So this is already a list of numbers. Just to confirm that, I'm pretty sure this is right. And then, but then again, we always think we're right until proven wrong. So we're gonna append the thing, and then at the end return ticket list. Let's run that. I have a bunch of map objects. That's not helpful at all. Why is it that here we have numbers, but here we have a bunch of map objects? Is it just because I haven't like appended it to the map? So let's see what that looks like. Oh, we can't see it because I'm not doing anything with it. So let's put nearby tickets and save that, rerun it. Oh, they are map objects. That is strange. I think what am I doing wrong here? I mean, I can convert it to a list. That's not the problem, you know? It's more that I am suspicious of the fact that, oh, it's probably because I have this and it unpacked it for me, and so it implicitly converted it, I guess, to a list. Whoops. So if I did that, then it works. All right, I can work with that. So we got a bunch of tickets in a list, in a double list, and the only reason we're doing that is so in case, or probably because, you know, later on we're going to have to like do a per ticket analysis, even though for now all we need to know is if when you identify the values that are not valid in any field. So now let's actually encode that logic. Basically all of the ranges we have, we need to read in and check each number for each of those ranges, right? So check ticket, check valid ticket. So that's like, we'll put in the nearby tickets, we'll put in the rules, and they will go and figure it out. So one more function here, define that. We have some tickets. Tickets, rules, and then we've got why did I do tickets first? That's fine. So first we need to read in these rules. Got to figure out for each of these rules, right? So for name, values, and these values are actually A1, B1, or A1, A2, B1, B2. I'm going to do dictionaries dot values, items rather, in our rules dictionary dot items. So now we'll have all of these ranges. We want to check the, we got to check every single rule. Should we check every number against every rule, or every rule against every number? Like, should I say, for this number, does it go into a rule or not? And if not, it goes on, you know? What I'm concerned about is numbers not fitting in multiple times. Yeah, we should go by number, by ticket. So the outer loop should be for ticket in tickets. And then for each of those, it's like for num in ticket. Then we're going to check against these ranges. For each of these ranges, it's like if the number is not between this and this, A1 and A2, if it is between A1 and A2, we're good. And if, or if it's between B1 or B2, we're good. And so I'm going to not that whole thing. If it's not that, then we're no good. So then we say invalid total plus equal number. So I'm going to create that variable here. And we have a very deeply nested for loop, but hopefully that will be okay. Is this, so that returns, and we have a number for this example. This is the number that it thinks it should be. That's number I got. Not loving that. Print num. So it's, oh, okay. So I'm seeing many duplicates. If it's not in the values on the first nearby ticket are all valid for at least one field. Oh, I think I got it backwards. Like it needs to be valid for at least one field, and once it is, then it's like out, right? So it's more that if it is between either between A1 and the A1 A2, or if it's between B1 and B2, then we need to move on to the next number. Continue. Because that means it's valid for one of the rules. I'm trying to figure out if it should be break, right? There's no need to check for additional rules. So yeah, it should be break. And it'll move on to the next number. The trouble is, if it is not, I need a way to find the ones that are not valid for any field. So let's see. If we get through and we find one that's valid, let's mark based on the length of rules. Okay, let's do a rules checker, kind of like we can get a kind of a list of Booleans of the length of rules. False, right? We're going to assume that it doesn't meet any of the rules. So all rules. I'm thinking we're going to need this on a different line. So we're going to move this down to here. So for each number, we're going to light up, set up all the rules, mark them as false. If for a given rule, but the rules are not, the rules are not numbered, they're named. All right. So, not loving that. If I made a dictionary of keys, I don't know if I want to make the dictionary that just has like the name of the rule and then false, but I may have to. All right, so this is false, and then a bunch of names. So rules dot, let's see if I can get this right. Keys, and then I'm going to zip them together and turn them into a dictionary. Ooh. So that should make a bunch of keys set to false. And so if it is in that range, then rules at name equals true. And then once we finish this for loop, at the end of going through all of the rules, then we say if any of the all rules dot values, right, if any of them are true, then this one's good. We don't need to add it. So it's more of if not any. If they're all false, then invalid total plus equals 1. That was a lot more work than I expected. Boolean object is not iterable. This is true. But why? Why did this break now rather than earlier? So the error is talking about the fact that rules.items is a Boolean object. I think I must have accidentally reused a variable somewhere. Length of rules times false. Rules.keys. All rules. It's not iterable. Rules.items. Rules.keys. Zip. Let's see what all rules looks like. But this should be a separate thing. Oh, I just didn't do anything with it. Okay, so that looks good actually. For ticket in tickets, we don't need this anymore. And what we could use probably is a quick printout of what the heck is in rules. Just a sanity check. So these are the rules, which, to be fair, look right. What does it think is a Boolean? And what's also interesting is that we have classes we go through what looks to be 2 cycles of that. Print all rules. So for num in ticket, we're kind of going through the various tickets. Print ticket. We're on the first ticket. Hey Gabriel, you just typed the letter P. All rules.values, rules.name equals true. This is where I blew it. I changed it on the fly. There we go. Doesn't mean I got it right, but it's a start. So let's see. Print the number. Okay, let's remove this printing of just all of the of the blank rules. And let's see, we printed out rules here. We print out each ticket. Scanning ticket rules. And then we're saying that one is valid. We said we know the 4, the 55, and the 12 are bad. So the 4 is getting found. So that's good. The 55 and the 12, they are all being found. And I'm adding 1 instead of the actual number. So that's my fault. So there we go, 71. Hey Gabriel, thanks for saying hello. It's great to catch you live. Thanks for joining me, giving me company. You know, I think we're there for part 1. Let's load in the full input and see how we do. So it thinks it's that. Who am I to disagree? Yes. 1 down, 1 to go. Let's go to part 2. We got that in 30 minutes. Yeah, probably, could use a little speedier go around here. Now that you've chosen to identify which ticket you've identified which ones are invalid, discard those tickets entirely. Use remaining tickets to determine which field is which. Yeah, that's fair. So when we encounter a ticket that is bad, also I want to know how many of them there were. So let me actually change this to a 1. Like I had there were 45 bad tickets out of from line 26 to 260. So out of like 230 tickets, 46 were bad. That's not too bad. Like we can still use this logic to later to do the ignoring. We can rerun some of that code. Using the valid ranges for each field to determine what order the fields appear on the tickets. The order is consistent between all tickets. You could have the following notes based on the nearby tickets in the list above. The first position must be row. The second position must be class. The third position must be seat. You can conclude that in your ticket, class 12, row 11, seat 13. Look for the 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? All right. How do we want to go about this? So I like just looking at some of these rules, right? Like every number on these valid tickets that have valid numbers that could work for at least one of these fields is going to we're going to want to associate a kind of, let's see, the fields have rules, and when we go through this ticket we say 3, and then we want to say, okay, we're basically reversing it. We're saying 3 is, instead of saying is it valid for at least 1, we're saying how many of these could it possibly be valid for. And in this case 3 is able to be in row, and that's it. 9 is able, or let's take a look at this 1, right? We'll get to 1 and it's like 1 could be class or row or seat. So it has like 3 different things. But we want to look at it by field. So it's like 18 could be any of them. 5 could be row or class or seat. It could be any of them. 9 could be seat or row or class. It could also be any of them. That's interesting. So it doesn't necessarily work out that everything kind of locks you like Sudoku style. It has to be elimination in both directions. You have to say once something locks a field, then other things can't use it. All right. So at some point I want to step back and consider whether I'm approaching this the right way at all. Because instead of using if statements, I could also reconstruct these as lists of numbers directly. Though admittedly these are small and the full input has some larger numbers. And so saying all of those out loud, right? Like some of these are like zone could be from 200 to 900. It's like that's a lot of numbers in between. So that's worth considering. Does Python do things like 9 in range like that? That works. So we could do something like that, but that's not that different then from just doing the if else, the if statements that we were already doing with A1 and A2, because we still need the upper end and the lower range, upper and lower bounds. But let's take a look at this example. 3, 15, and 5. So 3 cannot be class. 3 cannot be class, but it could be row or seat. 15 could be class or row. And 5 could be row or seat. And so you take the intersection of them all, and then you can, let me jot down how I want this to play out. So for each column, aka field, find the set of rule names that it's valid for. Intersection for each of all values in that column. Find the intersection of all values in that column. And then find which one or ones, specifically which sets are len equal 1. Then lock those in. Remove the names of locked rules from all sets. Repeat. Until all sets are equal 1. So we were able to say that, and in the example of the 9, 1, and 14, 9 is here is class 1. 9 works in all of them. 1 works in all of them. 14 works in just the first 2. And so that full intersection would be class and row. And because 3, 15, and 5, the intersection ended up being row, then that removed that from the running for everyone. So once that one is locked in as row, nothing else could be row. And then that caused the second one, which was class or row, to become just class, after which no one else can be class. So who remembers how to do set removal? Let me just do a quick check here. Okay. not what I expected there. There we go. Wow, come on. Okay. So a equals 1, 2, 3. A dot remove 2 or 3. A is now 1, 2. Okay, so we can do dot remove. Always good to check the API of what the syntax should be. So literally remove. All right, I think I've got some good pseudocode here. Man, we need to come up with a good way to reduce our tickets being considered, though, if I'm being honest. Because I got a bunch of things here and a bunch of things here. And so if I take check valid ticket and just take that and I'll put it down here, a copy of it, and I'll change it to get valid tickets, right? So it's like filter down the tickets that are going to be valid. So instead of totaling invalid plus num, let's see, where are we in the for loop here? For num in ticket, if that ticket is not valid at all, then so this changes how we play this. Instead of saying if any of them are true, right? Any of them are true. If not any of them, not a single one is true, we want to say well, basically if any of them are true, right? No. Within every ticket, every rule have to be true. Yes. Every rule, every value. So this number has to go and show every rule is true? No, no, no. It only needs to meet any rule. Because it's at this level, at the kind of ticket level I want to break out of. So at some point I want to append ticket to like a list of valid tickets. And in order to do that, I want to confirm that for every number in the ticket, it's not invalid. So here we have an invalid ticket. And so when we see that, if we just hit break, then I think we're able to maybe just say in ticket. So the number that's invalid in this ticket. And if I hit break here, then I'll be in the middle of processing a ticket and then be like, nope, stop processing that ticket. Go on to the next ticket. Yeah. But I also want to have it skip the so what is the so for number in, I want to say else, right? At the end of a for loop, if it succeeds without issue, I believe this is how this runs, append ticket. So this is when a for loop succeeds without breaking. For I in range 1, 2, 3, print I else print else. So it prints 1. Why does it only print 1? Oh, because range 1, 2, 3. Okay, so that's when it succeeds without breaking. And like actually let's make it, properly do something here. Good. 1, 2, 3, 4 else. And then instead we're gonna print one, and then just break, and it just prints 1. Great. So if we hit break, it never executes the else, which is the behavior we want. Man, a rare usage of the else in the for loop. So this should return valid tickets. And in the case of the small inputs, oh, I also need to steal the code from part 1 where we're parsing all of this stuff. Get that. And we're gonna call get valid tickets instead of check. And then this is valid tickets. We're gonna return valid tickets. We're doing the small input first, and we've got our various activities. Oh my goodness, why is that part 1 still running on the big input? Great. So we're scanning ticket, we found an invalid 4, and then it's scanning this ticket, invalid 55, and then scanning this ticket, invalid 12, and so the only ticket that's valid is this one. That was from part 1 for ticket validation. Good. So now the inputs for part 2 shall reveal themselves. All right, so we run that, and all 3 are valid. And now the crux of it is figuring out this little pseudocode blop that I wrote. I don't need this parser anymore. So we got our valid tickets, and so let's take our tickets, and do we need rules too? Yeah. All right. So what do we want to call this? We are finding I don't know, rule mapping or sequence rules, something like that. And we want our tickets and our rules, just like before. But this time we're gonna pass in valid tickets and our rules. And it's gonna return whatever it is they wanted you to return. Output. All right, let's do this. So in sequence rules, we're going to, for each column of our tickets, so for I in range, do I want to go through? I want to go through column by column, moving the other, yeah, so it's really for kind of J in range length of tickets at 0. So we're going to go through each column and go on the inside row by row down through the tickets. Tickets at I, J. Then we're gonna, yeah, it's gonna move row by row per time. Find the set of rule names that it is valid for. I'm starting to think I need to make this rules checker like a static thing, so it doesn't have to reparse it every time. Well, no, we have the rules here. Yeah. So for a given ticket, for a given number, really, we need to find which rules it satisfies. Yes? Okay, so for num equals that, and we want to find the set of rules that are in this range, but we want every single one of them. So here's our rules. We're going to go through every rule, and if the number is within the range of that rule, we're going to record the name of that rule in that set for that column. So that's here at the column level. We're not going to change that until we finish a column. So yeah, so this is rules satisfied, which I spelled wrong, or let's just say rules met. And we're going to, where should we store these sets? So this, it's going to scan and figure out the rules that this number meets. Then it's going to scan and figure out the rules that this number meets. So we'll keep adding to that set. Or are we intersecting? Back to the notes. For each column, find the set of rules that is value intersection of all values in the column. So actually this should move down. It's the rules met for a given number. So the number that comes out here, and then we'll append it to, we'll do the intersection at this top level, well, after the for loop. So we'll say this number meets the set of rules met dot add name. So that will be the list of all of the names that that number meets. And so if we want to do an intersection, we need to create a set of every rule, right? This is set, intersection, union. Yeah, so all of the rules that we have available to us. So that's rules that keys. So we're going to make a rule out of, make a set out of rules that keys. And yeah, that definitely will work because you can do sets out of lists, and rules that keys is like a list. So those are our names. We're going to do rules. Oh, no. Not here though. Close call, folks. Here. Do we need one with everything? Just to have something to intersect it with, right? So for J in range, so for each column, we're going to find the full intersection. And so, okay, all rules equals set rules dot keys. And so then we can say rules met dot add, and then all rules dot intersection of rules met. And this is going to be out here. We make a set for this, or is it out here? Because earlier that was just for a single number. We process the number, then we add the name of the rule that that number meets, and then we go up and we go to another row, so it's for I, so we're going down. Each time we go through one of these for a given column. No, I think this needs to be in one, because we're making a new rules for that number, and then we're going to add it to the, so it'll be a rules met will be a set of rule names. Then we need to intersect that list with the all rules list, It's a lot. So let's see. For each column, for each column, find the set of rule names that it's valid for. Yeah, easy for this to say. Find the intersection of all values in the column. So now I think what I need to do is here-ish, add all rules, or a new incarnation of all rules, whatever. Yeah, because each time it's going to call set and make a new thing. We're going to append it to a list of rule sets, I'll call them. So I'm going to have a list of sets, which at the end of, we'll go into phase 2. Phase 2. Find which are len equal 1, and then remove from others. And lock those in, etc. Right? And really, we don't need to, like when I say lock them in, what does that really, do I have to? Yeah, because I want to find the new ones that are equal to 1, like afterwards. So it's like, we find one that's length equals 1, we remove it from the other sets, and we should probably also remove that element from the list, or somehow mark it as like done, and have some kind of matching. Let's do rule sets, or it's really just the length of however many rules there are. So it's just the length of the number of tickets at 0. So that first row, that's what you need to multiply by a list of, what should we put there? Like, just put zeros. So these are rules list, final rules, just variations on the name rules. Okay, and then we're going to go through, and order matters here. So rule sets is our list of our kind of bunch of sets here, and we're going to say for rule in rule sets, rule s, just, yeah, like it's the single set. If the length of rule s equals 1, we're gonna do rules set. What do you do with the rule again? A dot pop. There's like pop value, pop. I think, yeah, we can just do pop. And yeah, pop should be fine. And so we'll say b equals that, and b is 1. Great. So when it equals 1, we'll pop that value. And that's the rule name to kind of put into final rules at position. Ooh, yes, we did not account for that. Enumerate. Okay, so final rules at I is the string that comes out of rules.pop. And now rules is 0, which is fine, I guess. I mean, in the end, we want them all to be 0. So can you do dot remove and have it remove something that's not there? So remove, if we try to remove 9. Oh, interesting. So it has to be a, oh, I remember there's like another, like not remove, but discard. Discard. Haha. All right, so discard will remove it silently or fail silently. So now we have this let's call this rule found rule. And so this is found rule, but we also need to, if we found it, remove it from all the others. So for rule R in rules sets, yeah, we just have to go through it again. Oh man, I feel awful about that. So the rule set dot discard found rule, and so if it is, then we go through, we discard, we put it in, we put it in, and then in the end, if we did this right, oh my goodness, this is the big moment. Like, what are the odds that I actually managed to pull this off? I'm gonna say pretty low, because I don't even know if I'm calling this function sequence rules. I am calling sequence rules 0, 0, 0. Great. Yeah, that did not work at all. Why are they zeros? That is the question. So let's see what rule sets looks like at the end of this first phase. Aha. So they're all three things. So we didn't intersect this quite right. Should be intersection. All the keys. So let's take a look here. Print adding name for num, right? Num number matches this rule name. Okay. And so at the end of this for loop, I'm going to say the rules met matches this list of this set of rules met. I'm just trying to reduce the number of prints. So 3 matches row seat, 15 matches row class, and 5 matches row class seat. And so the intersection of this, all rules dot intersection, print all rules. So why is it that all rules doesn't change? Is this one of these types of problems? Yep. Just needed to save the outcome. So it matches seat row, and now it's seat row. 15 matches. Wait, what is this supposed to be again? Oh, I see. And so it like reduces it down and down, down, and then yeah. I know there's a shortcut notation for doing intersection. I just don't remember it. So that looks good. Row class seat. That was what we wanted, right? Row class seat, and we want to work out which field is which. Let's do that first, and then we'll make the special version with the departure summing, yada yada yada. That's not great. So we have a problem, I would say. Yeah, a problem. So the final, see what we're printing here. So it's like I'm showing all these matches. How can it match so many things? Oh wow, I did not get very far on this print buffer. Okay, so I can't show every match for every number. No surprises there. So we're scanning ticket, invalid, yada, yada, yada. So let's get rid of that as well. So we have a handful of invalids. Rules are that. And then we have a print of the intersecting all rules, rule sets, print rule sets. So these are the kind of candidate rules that we have, right? And we say for each rule, it's the multi-pass problem. I think I need to wrap this whole thing in a while loop. We go through every single one, and the ones that are length equals 1, we go and then we remove it. But the problem is we have to go back, right? It's essentially recursive, but maybe I can get away with just doing it as a while loop. Rule sets, rule S. You know, I might do this recursively. I might pull this into a little thing to generate the final output here. So if I define a new function, define intersect, or eliminate rules, and we're going to pass in rule sets, and we're going to call eliminate rules, pass in rule sets, and save it back to rule sets, and we'll print it at the end. And I see, yep, there we go. So instead of printing final rules, we're going to return. Each time we call this whole thing, right? If everything's length is equal to 1, then we're going to say we found a rule. And final rules, yeah, so the big thing is we need to pass this final rules list around as well. Final rules, rule sets, final rules. So it finds a rule, it stores the final rules, it gets rid of all its corresponding ones, it gets to the end, and basically what should it do? It should then call, goes to the end, and because we do that pop thing, this is the part that is tricky, is that I'm popping out the value so it becomes 0. And so rule sets ends up in a kind of a funny position in the end. I should have printed them out because I think it would end up being empty. It'll be a list of empty sets. And so is that our kind of final state where we go through rule sets, and if they're all empty, then we are done? Which is a strange place to be, I gotta say. All empty equals true, and then we can say as we go through, if the length equals 1, like basically if at any point we find something, right, if len of rule S is greater than 0, all empty equals false. And so then out here, if not all empty This really should have been a while loop. Call and eliminate rules on final rules and rule sets. And then we can just return final rules again and print it out and see what it looks like. All right. Do we have a bunch of zeros or do we have a bunch of values? Yes. All right. So that worked. Pretty awesome. Pretty awesome. And now we can just say for, what is it? Based on, find the first position must be there. It's the third position, yada, yada, yada. Look for the 6 fields on your ticket that start with the word departure. Oh, I have to go get my ticket. What do you do if you multiply these 6 values together? I kind of want to just return rule sets and deal with the rest as a separate function. So let's return rule sets. So this is sequence rules. We got our field positions, and then so finally is find departure values, right? Given the field positions and my tickets, which I haven't processed yet. Oops. And finally, this is the output. I don't know where this none is printing from. I'll have to deal with that at some point. I think it's just because I wasn't returning anything in the old function. But we'll fix that soon enough. All right. So these are my tickets to check them against, which I believe is still a string. So my ticket looks something like that. So we split by new line, split by comma. Yeah. So my tickets dot split by new line. Wow, that did nothing. My tickets equals my tickets dot split by new line. My tickets equals my tickets dot split by comma. We'll do the mapping trick again. Map int over the entire list. So now we have a list of ints. And then we want to basically find the indexes where field positions, the string starts with the word departure, right? Yeah. So for field in field positions, I'll do enumerate again because I need those indices to pull it out of my tickets. If field dot starts with, pretty sure this is a string function, departure, then the ith value of my tickets is part of our solution. And we want the product of all those things, so we're gonna multiply that, start equal my tickets, and then at the end return the solution. And list object has no attribute split. Yes. Yes. Title, my tickets. So it's because when we split by new line, it made this and this, and I was like, oh, then it's unhappy because then you want to have a comma and then this, that should work. String has no attribute starts with. Oh my goodness, what is the actual attribute? Starts with. Starts with. Did I spell it wrong? I mean, that is possible. Start with. Oh my word. Map object is not subscriptable. My tickets came out to be a map. I have to convert that to a list. And we've got a number. Man, these are big solution numbers. Kaboom! Kaboom! That's what I'm talking about. All right, that's 2 parts in. 16 days down, 32 stars for the count. Hour and 13. Ooh. So that was a piece of work. 1 hour, 13 mins. Hope that was, I don't know, if not educational, at least somewhat informative. I think I'm gonna take away this invalid print just because it is really taking up a lot of space. print invalid. Where else am I? I'm probably printing invalid a couple times. I'll print the rules, that's fine. Invalid here. That's a big one. I probably don't need to print the whole kind of rules shenanigans either. Where am I doing that? This is why people use a aliased print statement, so they can turn off all the printing. And instead of printing the not completed rules, let's print out the completed filtered down rules, because that's much more interesting. So instead of printing out rule sets here, let's print out rule sets here after we've done the elimination. Yeah, we got rules, we got rule sets, and we got our answer. Looks pretty good to me. Let's fix part 1. Let's uncomment that and make sure that prints out okay. Yeah, prints out the rules, prints out the score. All right, I think that about does it for me over here. For those of you who are also down here in the snow on the East Coast, you know, stay warm. Hope you stocked up on some food and water, and we'll see you on the other side. Catch you tomorrow for day 17. What should we call this? Day 16. All the set filtering and rules. Ooh, all the string parsing too. But yeah, it's been good, and we'll see you tomorrow.